Hello friends, my name is Hamid. Today I'm working on this induction Maytag range. The customer's complaint is that the unit, everything works except the top. The top is induction unit on this. The display is completely blown in it. They think it's blown or it's dead completely. Nothing comes on. They turn on and off the breaker, unplug the unit for a couple hours, plugged it back in, didn't make a difference. The model number on this unit is Ymir8890as0, and it's located at the bottom drawer. When you open the drawer, it's located on the right hand side. It's located on the left hand side. So today I will show you how to go through some setups and diagnostic and find the problem. For doing the setup and diagnostic here, to do the testing here, we're going to need our multimeter, our drill, we need a Phillips drill bit and a piece of wood. I have it already there, and we may need one of the pliers, maybe a needle nose plier, and I'll show you how to find the problem and how to fix it. The first thing I'm going to do is I will show you the model and serial number on this unit. When you open the bottom drawer, the model and serial number is located right here. So this is our display board. Everything is being controlled from this display board, which is the user interface board. We have to turn on the power, press this button, as you can see, press it and hold it for a couple of seconds. It turns on the whole top. As you can see, nothing is working here. When you have these kind of issues, the first thing you want to do is unplug the unit. Unplug it, let it sit for a couple of minutes, plug it back in. If you still have no display, of course the inside of oven is working because the display here is working. You can see, you can start it, everything works perfectly fine. The first thing we are going to do is we have to open the top to see why the display is not working. In order to open the top, we're going to have to unplug the unit first, just to be on the safe side. We have one screw right here, it's a Phillips screw. Another one here, we're going to open both of these. And of course we need Phillips drill bit. When you remove these two screws, you want to lift up the oven glass and get a 2x4 and stick it right here and leave it like that. After that, we're gonna do some testings here. And in order to get the readings from this display, we're gonna have to pull the tech sheet out. The tech sheet is located here at the back. This is for service technicians only. When you open the tech sheet, it shows you how to go through some testings and diagnostic for the oven, not for the cooktop. But for the cooktop, we are gonna keep turning the page here. See, all of the information here is for the oven. The bottom part is the display. The tech sheet part number is this on English. And in order to get this tech sheet, we are gonna have to turn it. So here's all the information for the induction module here. This is our induction module located at the bottom of the cooktop. These two are for our induction burners or induction elements, and this tiny part, as you can see, is this part is for the user interface board. So we're gonna have to get some readings from this. Read some of the pins here. As you can see, this control board, there's two wires coming here as this part here. And in order to get some reading from this place, we're gonna have to look at this and see what's happening here. So if you look close, see the way the wires are going from here, goes to the control boards on the induction. You see this part is this induction module, all of this. You see these four elements, induction elements, they're here. long story short, we are gonna get some reading here. So if you look here on pin number 5, which is going straight here like that, and that area, the electrical cable or wires are coming out from here, goes there, and you see these are your electrical cable that goes from here there, and then this one goes from here to other side. And those two that I just show you are this one and that one. If you look close by again, we are looking for 5 to 10 volts DC. You see it says 5 to 10 volt DC here. Pin number 1 here. We're gonna check for voltage here, DC voltage. And the same thing here. You see this pin number 5 goes straight here. 5 volts DC, 5 volts 10 volts DC, 5 volts DC. We are gonna get some reading here when the oven is plugged in. When we plug it in, that's the time we are gonna get the reading here. And this is our multimeter. We're gonna select it to voltage, but we are gonna select the DC, direct current. Okay, I'm gonna plug in the unit. Before I plug in the unit, we want to make sure we are not touching anything. Nothing is touching the ground. We do not have any pieces of steel or anything or metallic things attached here or somewhere. The wood is completely safe here. The wood piece is holding this cooktop for me, and instead of asking someone for help. And at the same time, everything seems safe here. I'm gonna plug in the unit. I got power, and now I'm gonna use my meter to get the reading. You remember I showed you this part is, this part is, this part. And of course the reading I'm gonna get is, I will put my meter here, DC voltage, and here on the pin number 5, you're gonna have to check between pin number 5 and 1. You can see I'm getting 10 volts DC. Look here. So this side of the board is good, okay? And now I'm gonna have to get my reading from this side. I should have 5 or 10 volts DC. 293. If you're getting minus 223, you have to flip these probes, and then after that you're gonna get a good reading. Okay, so I'm getting 295 volts DC here. This is a wrong reading I'm getting. It's a bad reading here, good reading here, and because of that, there's we do not have proper communication between this display board and this generator housing board, which is here and over there. So that means we're gonna have to check something else here now. I'm gonna unplug the unit again. It's unplugged, and now we're gonna look at the wiring diagram again. The unit is unplugged, and when the unit was plugged in, I was still getting 10 volts here. I was getting 10 volts, 295 volts there, which was the wrong reading. I shouldn't be getting that much. If I was getting less, really less, like 2 or 3 volts, then I would still call it a bad reading. And on opposite, I'm getting 295 volts. That's also wrong. So that means I'm getting wrong reading here. I'm getting bad signals or bad power here. So let's look at the diagram again. This time we're going to focus on some other stuff to see what's causing this issue. We are getting wrong reading, but the display is still not on. I'm getting 10 volts here, 295 volts. Maybe the display board is blown, or maybe something else is wrong. We're going to focus back again on our wiring diagram here. If you look at the wiring diagram here again, we have inline fuse here. Where's the inline fuse? Right there, right there. If one of these fuse blows, it will also cause exact similar issue. So where's this fuse located? Now again, double check to make sure the unit is turned off. We are going to remove this burner. We are going to remove this induction element. Here you go, check the fuse there. We got the fuse in here. We're gonna have to check this fuse for continuity. On my multimeter, I'm gonna select this for continuity here with a beep. And I attach my probes to each other to make sure it makes noise. It's working. It's good now. Okay, so I'm gonna check between this part and that part. I should have continuity. I'm gonna check here and there. I do not have any continuity. I'm gonna pull the fuse out and check it again. I'm gonna use this needle nose plier. Hold it like that. Okay, here the fuse is out. And now I will be holding this fuse in my hand and testing it, just to make sure. Okay, nothing. See, I have continuity. I do not have continuity here. Okay, so that means this fuse is blown. It's a 15 amp fuse, and I'm gonna have to replace this and see how it goes after that. I found these 3 fuses, and I'm gonna check them for continuity. This one is good. This one is good. And this is one of the best, the most expensive fuses you can use. See, it's made of aluminum. These fuses are built that they never ever break. So why we have these kind of expensive fuses that's worth $1,000 or more is because they do not want you to replace a fuse anymore. These new manufacturers, the way they're making appliances, they're all garbage. They add these kind of fuses, so that way when you have a power surge or anything happens in the house, it blows your main control board, not this fuse. So I wouldn't call this fuse, I call this a scam. So never ever use these kind of fuses. I pulled this from another induction board right now. So the proper fuses are these ones. You can always use a 20 amp fuse and you're on the safe side too. So this is a 20 amp fuse. What I'm gonna do is I will reinstall this back in now. Again, remember, you always want to turn off the power when you do these kind of works. Okay. Remember, the fuse has to sit like that. I have to organize this area. This plier goes on other side. My meter goes away. This broken fuse and this induction element. Keep it there. The induction element. Double check your work and everything. Make sure everything seems okay here. Now you can put your cooktop glass back in. I'm gonna plug it in now, and the first thing you want to do is look at your display here when I plug it in. The display is on now. Okay, so the display is on, and of course this is on too. Okay, so I have to press on the power here. Did you hear that ting noise? The fuse blew again. Now I'm gonna try this, see nothing happens. I'm gonna unplug it again. And I will remove my induction element back again, keep it on the side, and check my fuse again. My meter is here. I have it on continuity test with a beep on, and I'm gonna check my fuse that I just replaced. Okay, so unfortunately the fuse is blown again. Okay, so I went through some of the testings that I could, and after replacement of the fuse, it's called slow blow fuse, it blew my fuse again. These fuses are also not cheap fuses, they are expensive fuses, the one I replaced, but I had it for free because I removed it from another induction module. So long story short, at the end of the day, we know that the fuse was the problem that kept the display off, and what caused the fuse is whole generator housing board. When we have a communication problem between the generator housing board and power supply boards on these units, it comes as a one module. It's called induction module assembly. It comes with two sets of induction modules. There's two control boards, and there's tiny power supply, and there's a cooling fan on the side. It's a black color. All of those would come in one assembly. So to fix this issue properly, you really have to replace the whole induction assembly, and that will take care of the problem. Remember, if you got this issue and you're replacing your induction module, it's very important to give your customer the estimate for the display board too, because at this moment, because I could not confirm if the display board is good or bad, it's possible that we may have a bad display board, but you can only confirm it after replacement of this module. In order to replace the module, it also does not come with these induction elements or induction burners. You have to remove all of them. It's easy to replace. Just take pictures, write the notes, and then remove all of these burners, and after that the module is located at the bottom of this. You replace it, and that takes care of the problem. Remember, replacement of the module is not going to fix the problem if you don't calibrate this. So when you replace the module, you want to sync the module board to the display board. You have to go through some coding. It's not necessary to do this in all the units, and once in a while on these units you have to reprogram the module to the display board, and that's how it works. If you replace your module, do not expect it to work, because your display board might be defective or it's blown, and in that case, anytime I go in a customer house for similar issues, I give them the estimate on my module assembly and my display board. If they proceed with the repair, I'm happy. I will order the part and take care of it. But if they didn't repair it, I will never just give them the estimate on this module and hope that it's going to fix the problem. Because what happens, you spend $800 or $1,500 on this module because the customer okayed this repair for you. You go in a customer house, replace the module, spend 1 or 2 hours. At the end of the day, you're still having the same problem. Why? Because your display board was also blown in it, but you forgot to give your customer the estimate. Now, when you're giving the estimate to your customer that the display board is also blown in it, your customer is going to be disappointed. They're not going to be happy from this news, because they thought they're going to spend $1,000 or $1,500 to repair this. They okayed, and now they have to pay more for the display. They're not going to proceed with the repair. So it's important to always give estimate on those two parts, module and main display board, and that will take care of the problem. Thank you so much for watching my videos. If you guys have any question, please comment below. Don't forget to subscribe to my channel, like my videos, and share it with others. You can also follow me on Facebook. It's called Hamid Appliances Repair. I will also show you the way I'm holding this glass in place. I'll show you the setup here. I needed someone's help, but no.